Hello everyone. My name is Roberto, and today I'm going to talk about Internet of Things application with OpenWhisk and Rust. Before I start, I would like to introduce myself. I'm an electronic engineer and PhD in electronics, and I am really fan of technologies and Internet of Things in particular. I love to create my own beer, and I work as a software developer at the IL Monkeys. We are a friendly remote company, and we are focused on serverless technologies. So now, let's talk about our project motivation. We want to explore the use of serverless technologies using Internet of Things application. On the other hand, we want to have access to the information in real time, but we want to have also a flexible architecture and not tied to any particular cloud provider. So because I am really fan of beer and connecting with the previous presentation, all of you today will know how to create your own beer using serverless solution. So in this case, we are going to create the first part of the process. So we have 2 tanks where we have some valves, some pumps, some heater and temperature sensor in the middle. So now all this Internet of Things system, is modeled or is working using MQTT, which is a well-known serverless, well-known Internet of Things protocol. So we want to have access to store all the information in a database. We want to have access in real time using a dashboard, and we want to have notification in real time. So in order to do this, we are going to need some kind of magic in the middle. This kind will be provided by OpenWhisk. OpenWhisk is a serverless platform developed under the Apache Software Foundation and is adopted currently by IBM and Adobe as their main serverless platform. It's a multi-language environment, and it's really cool to develop with because it's based on Docker. So just running a Docker Compose app, you have a fully serverless platform in your computer. Now let's talk about the architecture. We have several functions running inside OpenWhisk. The first one is in charge to save measurement in a DynamoDB. We have another one that restream the measurement using a socket using real-time framework. We have another one function that check the measurement in order to decide if we need to dispatch an alarm or not. And finally, we have another function that send a real-time notification using a Telegram bot. We need another useful function in order to query DynamoDB, and in combination of the real-time framework, the socket, and this function, we are going to populate our React dashboard. So the only thing that we are missing is the connection between MQTT and OpenWhisk. This connection is done using a trigger. The trigger will be create a public endpoint in OpenWhisk. At that endpoint will be called by MQTT bridge. So here is an example of the code. The code is really simple. In this case, we use Rust, and you receive the data using a JSON string, using a standard input. You process and you do all your stuff, and then you only need to return the result using also a JSON string. Okay. It should work. Try to escape.
It's still flickering, yeah, and then I'll just put it back like it was.
We can try to put here.
I'm sorry.
No problem. Let's see now. Much better, I think. So the only thing that we need to do with our setup is map all our function inside OpenWhisk. OpenWhisk provides a command line interface, and with that command line interface, you can map all your function inside the system. So with this command, we map our measurement that saves measurement inside the function, inside DynamoDB. Then we have the other function that send the message using a real-time framework. And then we have to connect both using a sequence. Then we have another function that queries DynamoDB. We add the same for the other function, just define the both function and create the sequence. And finally, we need to create the trigger. The trigger is really nice because it will create, on one hand, it will create a public endpoint that will be called by MQTT. And on the other side, it will dispatch in parallel the both branches of code. So all the code inside OpenWhisk will be run in parallel. So finally, here we have an animation of the system. On the left, we have a Telegram channel where the Telegram bot is posting messages. And on the right, we have the system working, where we can see how the system is working and how is where is the measurement, etc. So here are some references related with the project. We have the repo, we have a Medium article about it, and general reference related with OpenWhisk and Rust. And before leaving, I would like to talk about Made for Serverless, which is our last project. And it's a driven community catalog of serverless solutions, serverless tools, where you can find documentation and information about serverless library, framework, etc. So thank you very much for your attention.